Hello everyone, hope you all are well. Now after discussing entropy, today we will discuss the spontaneity in terms of entropy change. Both terms we are familiar. Entropy is the degree of randomness and spontaneity is reaction is visible, reaction takes place by its own or it's not take place. Now there are two examples. Spreading of ink in water. If we put ink drop in the water, then it will spread in complete vessel. For this, there is no change of matter, there is no exchange of matter. So we consider it as an isolated system. For such system, delta S is positive. For such system, delta S is always positive. Now, second example, cooling down a cup of tea. In this case, there is the change of matter, transfer of energy, transfer of heat. Heat is transferred from one form to another. So, there is the change of matter. So, in this case, delta S is also positive. How it is positive? Because delta S total is equals to delta S system plus delta S surrounding. So it depends on these two factors. So delta S total will be more than 0. It is more than 0. So it will be positive. So we concluded from these two examples that delta S should be positive if the reaction is spontaneous. So we conclude, so delta S is equals to positive for the reaction to be spontaneous, and delta S is negative, reaction is non-spontaneous, and delta S is equals to 0 at equilibrium. This is the spontaneity in terms of entropy. Now we will discuss Gibbs free energy. Next thermodynamic property is Gibbs free energy. We call it as Gibbs function. Gibbs function as well as Gibbs energy. Similar like entropy, it is also a state function. It depends on initial and final conditions. It is represented by G. So its expression is G is equals to H minus Ts. Here G is Gibbs free energy, H is enthalpy, T is temperature, and S is entropy. Now if we talk about the isothermal condition, in isothermal condition, temperature is constant. So T1 is equals to T2, which is equals to T. And initial conditions we are taking, that are G1 is equals to H1 minus T is constant. So T and S1. Final conditions will be G2 is equals to H2 minus TS2. Now, subtracting first from second, this equation will be subtracted from this equation. So we can write G2 minus G1 equals to H2 minus TS2 minus H1 minus TS1. H2 minus H1, we can write it as H2 minus TS2, open the brackets, minus minus plus TS1. We can write it as H2 minus H1. We can take negative sign here. Then taking T as a common, S2 minus S1. So further we can write it as delta G. We can write it as delta H minus we can write it as T delta S. So this will be your final expression for free energy change. This equation we have derived This is known as Gibbs Gibbs-Helmholtz equation. So this is all about Gibbs free energy. Now we will discuss spontaneity in terms of Gibbs free energy. First you will see this delta G depends on delta H and delta S. So here four possibilities. First is both negative. Second is both positive. Both means delta H and delta S. Delta H positive, delta S negative. Here delta H negative and delta S positive. These four cases will be possible. Now first we will consider this one. This is the equation. Delta G is equals to delta H minus T delta S. First, we will discuss from here. Delta H is negative. If this delta H value is negative and delta S will be positive, then this whole expression will be negative and this is also negative. So delta G will be negative. For this case, delta G will become negative. So when the delta G will become negative, then the reaction is spontaneous. Always. It will always be spontaneous. Now come to next. Delta H is positive. If we consider delta H positive and delta S negative, negative, positive. This is already positive. Then what will be the delta G? Delta G will become positive. When the delta G will become positive, so this reaction is non-spontaneous always. Now consider next expression. If both are positive, delta H is positive and delta S is negative. Delta S is positive. When both are positive, it will become negative. It will become negative and it is positive. Whose expression will be more? The value of whom is greater. Now, if we talk about the next factor, temperature. If temperature is more means this negative value is more. If negative value is more, then delta G is negative and it is spontaneous. In reverse, if temperature is less, if this value is less, then this negative value is less. If this negative value is less, then this positive value will be more. So delta G will become positive and the reaction will become non-spontaneous. So this is this case. Means it has two possibilities which depends on if temperature is more, then delta G is negative and reaction is spontaneous. And second case is if temperature is less, delta G positive and reaction is non-spontaneous. Now come to last case, if both are negative. Now if we put both negative, this will become negative, positive and this will remain negative. Now again the same situation arises. Here it is negative, here it is positive and the expression of that sign will be more whose value is greater. So now again we consider the third term, temperature. If temperature is more, now if temperature is more, If temperature is more, then the entire positive value will be more. If positive value will be more, then delta G positive and reaction is non-spontaneous. And further, if temperature is less, this positive value will be lesser than this negative value. So delta G will become negative and the reaction is spontaneous. This is all about the spontaneity of reaction in terms of Gibbs free energy. Now, in the continuity of free energy change, we will discuss standard free energy change and energy of formation, which is represented by delta G naught reaction, and for energy of formation is delta G naught F. First, delta standard free energy change of reaction. When reactant in standard state, when we consider any reactant changes into product, reactant is changes into product, and we are considering this reactant is in standard state and this product is also in standard state, then the free energy change is called standard free energy change for a reaction. Next, energy of formation. When 1 mole of a compound is formed from its elements, suppose carbon plus oxygen will form CO2. 1 mole of compound, 1 mole of CO2 is formed from its elements taken in their standard states, if these two are considered in standard states. And 1 mole of CO2 is formed, then it is called energy of formation. Standard free energy change for a reaction is represented as summation of, this is a sum of delta G naught change in formation, energy of formation of products, minus summation of change in free energy formation of reactants. This is the way to calculate the standard energy of formation. Standard energy change for a reaction with the help of standard energy of formation. Now we will discuss free energy change and chemical equilibrium. This free energy change is related to standard free energy by this expression, delta G is equals to delta G naught plus RT ln Q. Here Q is the reaction quotient. It is represented by Qp when reactants and products are present in gaseous state. And it is represented as Qc when the reactants and products are in solution form. So basically this Q is reaction quotient. Now if we talk about at equilibrium, what will happen? At equilibrium condition, we already discussed that at equilibrium this gives free energy change is equals to 0 and this Q will be equals to K. So when we substitute these values in this equation, what you get? Delta G naught is equals to plus RT ln K. We can rewrite it as delta G naught equals to, when we take this here, minus RT ln K. So this will be the relationship between standard free energy and chemical equilibrium. So this K represents the equilibrium constant. We can also write it as in another log. This is a natural log 2.303 RT log K. These two are the relationships between standard free energy and equilibrium constant. Now we will decide the spontaneity on the basis of this K value. If there are two possibilities, if this K value is positive or if this K value is negative. This means if K value positive means greater than 1, K value negative means less than 1. If this K value is positive, now see here, If this K value is positive, this whole expression will be positive. Here is the negative sign, plus minus minus. So delta G naught will become negative. If it will become negative, then we can say that the reaction is spontaneous. So if delta K is positive, then delta G negative, so reaction is spontaneous. Now think reverse. If K is negative, if this K value is negative, then this whole expression will become negative. If this whole expression will become negative, then negative negative positive, then this delta G naught will become positive. If this delta G becomes positive, then the reaction is non-spontaneous. This is whole about the second law of thermodynamics, spontaneity, Gibbs free energy, entropy, all things will be done. Now we will discuss third law of thermodynamics. According to third law of thermodynamics, the entropy of a perfectly crystalline substance. We have studied that solids exist in two forms, crystalline and amorphous. Crystalline are hard solids. So, perfectly crystalline substance at absolute zero temperature is zero. The entropy, कोई भी perfectly crystalline substance है, उदी entropy absolute zero temperature पे zero होगी. This will be the statement of third law of thermodynamics. That's all for today. For more such videos, kindly like, share and subscribe. Thank you and have a nice day.